Welcome to our lesson video for Chapter 1.1. This is going to be a review of factoring. This is a topic that we covered heavily last year in Integrated Math 2. I would encourage you to get out a notebook and some paper to take notes on, just like you would if you were in normal class, just as if this was me giving a lecture and you wanted to make sure you got down all the important information. With that, let's go ahead and begin. This lesson is going to be about factoring. We're going to review a variety of factoring procedures that we talk about. We're going to review greatest common factor. We're going to talk about the diamond method, which is a way to factor trinomials. The long diamond method, which is another way to factor trinomials of a different form. We're going to talk about difference of squares, and we're going to talk about grouping. So let's talk about greatest common factor first. So greatest common factor is something that a lot of us do really quickly. We do it in our head, and that is totally fine. I'll show you a procedure to do it by hand, but most of the time you do this in your head. What you're going to do is find the greatest common factor. You're going to list out all the common primes and find what they have in common. You can then divide that greatest common factor out. You make sure you write it on the outside, and then you write parentheses around what was left over. Remember, if there is a leading negative, we have to factor it out. So if the front value is negative, we have to factor that out as a greatest common factor, and that would just mean you take the negative out and then switch all the other signs. So let's go ahead and begin. I'll show you how we would find the greatest common factor. You most of the time do this in your head, but you could also list the prime factors. 2x and x, 2, 3x, y, 2, 2, 3x. You can then go through and see what these have in common. They all have a 2, and they all have an x. This is our greatest common factor. We can write it on the outside of our parentheses, 2x, and then we can write everything that's left over on the inside. The first value would be an x plus a 3y, and then there was a subtraction right here, so this would be a minus 2 times 3 is 6. Now most of us look at this original problem, we see the 2x, we pull that out without doing all that, or kind of that process gets done in our head, and that's totally fine. Our next method we're going to talk about is the diamond problem. So the diamond problem is something we do for trinomials. We normally do it right off the bat if there is no coefficient in front of the x squared. Sometimes we would factor out a common factor if there is one, but if there's no coefficient and it's just an x squared, an x, and a constant, we can go ahead and do the diamond problem. We need to identify our a, b, and c of our quadratic. Our a is in front of the x squared. In this case, it's 1, so we use diamond problems when a is 1. Our b is 2, and our c is negative 8. To do the diamond problem, we're going to draw a large x. On top, we are going to put our c value, that's negative 8. And on bottom, we're going to put our b value, that's 2. You're then going to go through in your head, and you're going on the paper or in your head, and you're going to list all the things that multiply to negative 8. Some of us have gotten really good at these, and we can just see it and do it right away, but you might have to do this, and that's fine. 4 and negative 2, negative 4 and positive 2, 1 and negative 8, negative 1 and 8. Then you're going to ask yourself, of these things, if I were to add them together, which one gives me the bottom of the diamond problem? Which one gives me 2? 4 and negative 2, that's the one that's going to do it. Let's check the other ones though. Negative 4 and 2, that's negative 2. Negative 8 and 1, that's negative 7. 8 and negative 1, that's positive 7. So this was our best option. So the two numbers we put on the sides are 4 and negative 2. The diamond problem is just a tool we use to help us factor. Some of you may have learned other methods at other times. That's totally fine. You're basically looking for what two numbers multiply to negative 8, the top, and what two numbers multiply to 2, the bottom. So what multiplies to c and adds to b. I might have misspoken there. Multiplies to c and adds to b. So multiplies to negative 8 and adds to 2. Well, that's not actually the full problem. We have to write our answer now. So you're going to take those two values on the side, and you're going to write them as binomials. So you'll write x positive 4 and x minus 2. Box your answer. This has now been factored. All right, here's a practice problem for you. Use what we've talked about so far and give it a try. All right, hopefully this is what you did. Right off the bat, you saw that there was a common factor, 2x squared, 22x, and 20. We can pull out a 2. So right off the bat, you pull out the 2. You're left with x squared plus 11x plus 10. Now that you've pulled out the common factor, you go ahead and do the diamond problem. You say, all right, what multiplies to 10 and adds to 11? This might be tricky for some people at first. You kind of forget this one sometimes. It's going to be 10 and 1. 10 times 1 is 10. 10 plus 1 is 11. Don't forget that 2 that we pulled out earlier. Rewrite it. And then you write x plus 10 and x plus 1. There is our final answer. This is now fully factored. Make sure you go all the way. Make sure you do the greatest common factor and then continue and do any diamond problems or any more factoring there might be. Our next process is called the long diamond. Now this is a really busy page right off the bat. The top part is kind of the first thing you should look at. If you get a quadratic like that last example where there's a number in front of the x squared, your first option should always be to try and pull it out if you can of each term and make it so you have just an x squared with nothing in front. If you can do greatest common factor and then do a diamond problem, that is your best option. However, that doesn't always work. If we look at this example right here, 7, 29, and 4, there is no common factor. There's nothing we can pull out to make the x squared by itself. So instead, we're going to use something called the long diamond problem. So the steps are listed out here to the right. Rather than putting the c value on top, we're going to multiply our a and our c value, that's 7 and 4, on top. We're going to put our b value on bottom. You do your normal bottom or your normal diamond problem. You multiply for the top and add for the bottom. You get your two numbers on the side, but now this time you're going to do something special. Since you multiplied by a up here, you have to undo that. You're now going to divide by that a value. So you're going to take your two numbers on the sides and divide by that a value. There's something on the bottom that says flip the leftovers and write as binomials. So let's go ahead and let's just do the example because that's going to help that make a little more sense. So first things first, we will draw our diamond problem. On top, you're going to put 7 times 4, which is 28. On bottom, you're going to put your b value, which is 29. You're going to think to yourself, what multiplies to 28 and adds to 29? Well, that is 28 and 1. 28 times 1 is 28. 28 plus 1 is 29. Now, since we multiplied by a earlier, we now have to divide that a back out. This is a step that people often forget. Don't forget it. Please remember to do it. So you're going to divide by your a value. Well, our a value is this number in front, so you're going to divide each of these by 7. If it divides nicely, that's great. 28 divided by 7 is 4. Usually at least one of them will divide nicely. However, this other one over here, it doesn't divide nicely. So that's going to help us write our final answer. This one we just write like normal. So your binomial ends up being x plus 4. That first one simplified to a 4, so it's just x plus 4. The one that didn't simplify, or maybe sometimes both of them don't simplify, you're going to take the denominator, the bottom number, and you're going to put it first. So you're going to make it 7x plus 1. Now, with the easier factoring methods that we talked about before, I didn't really mention this, but when you factor, you can always check your answer by distributing back out, by multiplying it back out. Is 7x times x 7x squared? Yeah. Is 4 times 1 4? Absolutely. 7x times 4 and x times 1, add those together, you get 29x. That means that this is our correctly factored answer. All right, so that's our long diamond method. All right, go ahead and give this example a try. What you should have done is you should have drawn the diamond. You should have put 3 times negative 20 on top, that's negative 60. And you should have put negative 11 on bottom. You say, what multiplies to negative 60 and adds to 11? Well, that's going to be negative 15 and positive 4. You'll take both of those values, you'll divide by the a value, which is 3, divide by 3. Negative 15 divided by 3 is negative 5. 4 divided by 3 doesn't happen. You'll write your final answer x minus 5, 3x plus 4. All right, our next method is really more of a memorization method. It's really something that you'll have to learn to recognize. A lot of times I'll ask you to factor and I'll give you a binomial. Binomial means two terms, 1, 2. If both of these terms are values that can be square rooted, so 9 and x squared can be square rooted and 16 can be square rooted, then it's what's called a difference, meaning subtraction of two squares. So it has to be subtraction, and you have to be able to square root them for a difference of two squares. If that's the case, then it always factors in a special pattern. This pattern goes like this. You do two parentheses. The first value in each parentheses is the square root of your first term. The square root of 9x squared is 3x. The second value in each parentheses is the square root of the second term. The square root of 16 is 4. Now one parentheses gets a plus sign and one parentheses gets a minus sign. You always check to make sure everything's fully factored. In this case it is, and you box your answer. So you need two terms. Both of them have to be able to be square rooted, and there has to be a subtraction sign. If you can take the greatest common factor or something first, make sure you do that, and then you can do your difference of squares. Go ahead and give this problem a try. Might be a little tricky. All right, so we look at the problem. We have two terms. I can square root that. I can square root that. Subtraction in between. So what I'm going to go ahead and do is I will draw two parentheses. The square root of x to the fourth is x squared. The square root of 16 is 4. One gets a plus, one gets a minus. Now be careful. You might have said, I'm done. I can stop. But look, we have another difference of squares. You always have to make sure you're completely factored. So we'll factor that one again. The first one stays the same. It is not a difference of squares because it has that plus sign, so it stays the same. The second one, however, you can square root both of those, and they're separated by a subtraction, so it happens again. The square root of x squared is x. The square root of 4 is 2. 1 plus, 1 minus. This is now our final answer. No more difference of squares because this term that has the subtraction now, that is not square rootable. That is not square rootable, so it is no longer a difference of squares. All right, our final method is called the grouping method. We factor by grouping. We use this most often when we have 4 terms. So 4 terms here. What we do is we take the terms and we group them into 2 sets of 2. In the first set of 2, we look for a common factor. In the second set of 2, we look for a common factor, and we look to see if that creates a common factor between them. So we'll take our first set, we'll take our second set, and we'll do the greatest common factor. The greatest common factor of the first set is 2x squared, leaving us with x plus 3. The greatest common factor of the second set is 5, leaving us with x plus 3. I always like to remind myself that there was this plus sign right here, so I'm going to rewrite that right there as well. Now, look what this did. We now have 2 pieces here, 2x squared times this parentheses, and 5 times this parentheses. Well, what do you notice is that that parentheses is the same. It's our new common factor. So we can go ahead and we can pull that out. X plus 3 gets pulled out. And then we say, well, what did we have left over? Well, once I pull the x plus 3 out of this part, I'm left with a 2x squared. And what's left over is a plus 5. So I can go ahead and put a plus 5. So here is my fully factored problem, x plus 3 times 2x squared plus 5. This is factoring by grouping. You do the greatest common factor of the first 2, the greatest common factor of the second 2. You pull out the common factor. It should hopefully create a new common factor. If it doesn't, then you're not able to use grouping, and that's okay. You pull out that new common factor and put what was left over as your second binomial. All right, this is our last slide, our last example. Go ahead and give this a try. All right, so this one was a little different because it doesn't have a squared, but we can still do grouping. You take your first 2 and your second 2. The common factor from your first two is x, leaving you with a minus 2. This common factor from the second two is a y, leaving you with an a minus 2. Hey, look, these both have an a minus 2, so we can pull that out in a parentheses, a minus 2. And left over from the first one, we had an x. Left over from the second one, we had a plus y. So we get a minus 2 times x plus y. This is our final answer. We can box it because we are finished. As always, with every other type of factoring, we're going to make sure that we check to see if it's completely factored. Our one last thought is here's kind of your checklist of things to look for when you're factoring. Look for GCF. Check to see, is it a diamond? Is it a long diamond? If it's not one of those, check to see, is it a difference of squares? Is there two terms separated by a subtraction sign? If it's not that, check to see if it's grouping. There can always be a combination of these. It can always be greatest common factor and one of the other ones. If you do not see one of these, then it might not factor, and that is okay. We will also be learning some more factoring methods later in the year, so hold tight and we will learn those soon. You should now be ready to go ahead and begin the assignment. I would encourage you to do so. If you have any questions, we can ask them during class when we go over this, or if you have a more pressing question, reach out to me on Remind or through email. Have a great day, and I'll see you in class.